there. I'm going to give you 4 minutes to factor, so till 8:53. On the bottom, just a heads up. Remember, if you're using, this is not just the answer. It's not just x minus 3 times x minus 8. You have this 3 in front. Remember we talked about how to factor differently if a is greater than 1.
Thank you.
someone share for the first one what you should get on top and bottom? Should I have Hannah?
10 and 9.
10 and 9, and how do I write this out?
X plus 10 and X plus 9.
Perfect. Okay. The next one across, what do I get, Isaiah?
You get a x minus 7 times x, but you get a negative 5, then it's negative 7, then it's 2, x minus 7.
And what's my
Times x plus 2.
X minus 7 plus x plus 2. Below, what are my two, Brianna? 16 and 1. So the only issue here is I saw people just write like x plus 16 times x plus 1, or like put a 2 outside. Can someone remind us of what this actually represents here? It's not just x plus this number, x plus that. Alana?
It's going to be 2 times x plus 16 times x plus 1. The parentheses, like the 2 and there's the parentheses, the x plus 16.
Not quite. Chris?
It's 2x to the second plus 16 plus 1 plus 8.
He's on the right track. So like this 16 and 1.
Well, 16x plus 1.
Okay. So let's turn to Chris real quick because I want to make sure we're all listening. Repeat that for us. Go
You
ahead.
should repeat it?
Yeah, sure.
Okay. I said 2x to the second plus 16x plus 1x plus 8.
So these two, so 16 and 1 represent what I'm expanding this to be so that we can factor in. Can someone pick it up from here? Like, hopefully this is reminding us of some things. What do we need to do now to factor this? Even.
Split them up.
Okay. So split the first two, and yeah, what can I pull out?
2x.
So I can pull out a 2, more than just 2. So I can pull out a 2. Okay, x. What's left? Someone else raising a hand inside. So 2x times what gives me 2x squared? 2x times what gives me 16x? Isaiah.
X plus 8.
Okay. So we know the first one is x plus 8. What do we need to do for the second one? Brianna? Well, I can pull out a 1, but I know that this one also, if this is x plus 8, this is x plus 8. And you're right, we can just pull out 1. Because 1 times x is x, 1 times 8 is 8. So what is our final two binomials now? It's the final step. What's our two binomials? We're so close. Anthony?
2x plus 1.
X plus 8. So 2x plus 1. And then what's in the parentheses is our second binomial. Okay. So with that, I feel like most people didn't have this for this one. I'm going to give you a minute, go back, try this one on your own, and we'll come back together. So this one is very similar to the last one we just did. So see what you can pull out. Alright, someone feel like they've got it. Let me check. Okay. So let's look at Isaiah. There's depends on how you wrote it. So if you put negative 8x or negative 3x first, so he chose negative 8x first. If you do that though, so you're left, you can pull out, the only thing you pull out is an x. So you get, ooh, there's one small issue. What do you see? Nathan, or Ethan?
I was gonna switch it around, so I did it 3x squared minus 3x.
Mm-hmm.
Yeah.
You're right, and I'm going to show that one in a minute, but what's, like, this way works too, but what's one issue with what he pulled out? Brian, so? Pulled out x? What do you mean?
I mean, like, at the beginning.
So you pull out one.
X, but yeah, that's, multiply to 8.
So wait, so what should this be? So I'm asking.
8.
It should just be just 8. So like this should be 8. So here's the way it works. So you just get x minus 1 and 3x minus 8. So to Ethan's point, did someone solve it the other way where you had 3x first and then 8x second? You did? What did you, so what did you pull out for that?
I pulled out 3x for the first one,
Okay.
and then I got x minus 1. And for the second one, I put out negative 8. And yeah.
Okay. And what was your two binomials? So you should be checking either you had it Isaiah's way or you had it this way. Or what did you get when you had your two final binomials?
3x minus 8 and x minus 1.
X minus 1. So that works as well. Perfect. Okay. So down below, we're going to take, this is what we've been practicing thus far, is just factoring. We're going to look today at solving. So there are a couple of steps first. So the first step is to factor completely like we've just been doing up above. And once you have your two sets of factors, so I'm going to put this and write in an example to the side. So simple example, this is just the space below. Question? I did have your paper. We're going to use the first example just because I think it's a simple one. So it was x squared plus 19x plus 20. Now add one other thing. We're going to make this equal to 0. I didn't want to add that up above. It'd be a little more confusing. So this is what makes it then an equation rather than just a polynomial equal to. Second step is after we have our factors. We had those. They were x plus, x was 4. Wait, what did I just do? Why did I put 20? Okay, I just realized that. It was 90. It was 90. This should be 90. My mistake. So we had x plus 9 times x plus 10. That's equal to 0. So previously we had stopped here. So now to solve this, we're solving for what x equals in this case. We're just seeing which one of these can make this statement true. So this is one binomial times another equals 0. So what does x have to be so that if I multiply these two together, I get a product of 0. So like x could be, in this case, if I want this to be 0, can someone tell me what I want x to be? And I want this binomial to be equal to 0. What does x have to be for that to be the case? Michaela? Negative 9. So that's one of them. Or if this one's, only one of them has to be equal to 0, because any number times 0 is 0. So what does this have to be? X have to be here if I want this binomial to be equal to 0. Austin, negative 10. Negative 10. So all we're doing here simple set each binomial equal to 0. Yes.
So, but like we already said 1 to 0. Why you gotta set the other to 0?
You're right, because we want to have both solutions. So like we want to know if this, we want, because it could be either of them could be 0 to make this statement be true. So like I could have x be 0, or I could have x be -9 here, and this is 0 times whatever this is, gives us 0. Or this could be -10, and this is 0 times whatever this is. So to solve this, I would put x plus 9 equals 0, x plus 10 equals 0, and just solve for x. So I subtract 9, negative x is -9. Subtract 10, negative x is -10. So these are our two solutions. So we're just adding one extra step to this. And these solutions are actually, if I was to graph this, these are the x-intercepts. I'm going to draw like the smallest sketch here of what this graph would look like. It's squared. Does anyone have an idea of what that graph, what the shape is? I've got married if you do. This is a little bit tricky. So if it's a square, what is the shape of my graph look like? Veronica? Is it a U or a Y? Which one is it? Trinity, what do you think? I'll give it to you. So we're on the right track. So yes, it is a U shape. It's called a parabola. And it would look parabola. So it looks like so. And I would have, oh, I just realized they're both negative. I just made a silly mistake. Ignore my graph. So it should be more like this, with a point passing through -10, 0, and -9, 0. So those are the 2 points which it passes through. And we'll talk more about sketching these later on. Yep, it's still a parabola. And it can be upside down if it's negative, but we'll talk about that too. Okay, so for the examples down below, I want you to, I'm going to give you a minute, go ahead and factor this. And if you think you got the last step of setting it equal to 0 and solving, do that as well to find the two solutions. Don't do graph. No, don't worry about graph. All right, someone raising a hand. What are two terms that add up to 12 multiplied by 35?
Get 7 and 5.
7 and 5. How would I write
X
that?
plus 7, X plus 5.
X plus 7, X plus 5. Can someone tell us the next step? Do we want to